You ever wonder how a platform like Netflix or Amazon can handle millions of people all at once and just not crash? Well, the secret isn't some giant, super powerful computer. It's an idea, an architectural revolution that has completely changed how the digital world is built.
Okay, so let's jump right in. What we're really talking about here is a clash between two big ideas. On one side, you've got the classic monolith. Think of it as one giant, single building where everything is connected. And on the other, you have microservices, which is more like a whole city of smaller, independent buildings. And the differences? They're night and day. We're talking total dependency versus true independence, making a small change being a high-risk gamble versus a low-risk update, and a totally different way of thinking about growth.
But to really get why microservices even exist, we've got to look at the giant they were designed to replace, the monolith. For the longest time, this was just how you built software. It was the only game in town. So what exactly is a monolith? Well, picture one massive chunk of code for the entire system. I mean, everything. User profiles, the product catalog, the shopping cart, it's all tangled together in one place. Every part is deeply dependent on every other part, and they're usually all sharing the same language, the same framework, and the same single giant database. And look, that sounds simple at first, right? But trust me, that's where the trouble starts.
Here's the number one problem in a nutshell. Because everything is so tightly woven together, one tiny little change over here can cause a massive, unexpected disaster over there. You try to update the shopping cart feature, and suddenly, nobody can log in anymore. The risk of the whole thing collapsing like a house of cards is just enormous.
And then you've got the scaling problem. When your app gets popular and you need more power, a monolith gives you one option: scale up. That means you have to buy a bigger, more powerful, and way more expensive server. But what happens when you max that out? Microservices, on the other hand, scale out. You just add more cheap servers whenever you need them. It's the difference between trying to build one skyscraper taller and taller versus just building out a new block in the city.
So you've got this combination of massive risk and really limited growth. A huge problem for any company that wants to move fast and innovate. They were completely stuck. It was obvious a new approach was desperately needed. So, what's the alternative?
And this brings us to a totally different way of thinking about software. Instead of that one giant skyscraper, what if we built a sprawling city of smaller, independent services, where each one has its own specific job to do? This right here is the big idea behind microservices.
All right, so the fancy official definition is that it's a design approach where you break one big system down into a bunch of small independent services. And the key here is how they talk to each other, not by messing with each other's code, but by communicating through well-defined APIs. Think of it like they all have official phone numbers and mailboxes. It's organized and clean.
So let's break down the principles that make this work. First, the services are small and loosely coupled. That's just a techie way of saying they aren't all tangled up. Because they're small, a single focused team can own a service from top to bottom with its own separate code base. And this is huge. It means that team can deploy updates whenever they want without having to coordinate with the entire company. It even supports something called polyglot programming, which is super cool. It means the payment team can use one programming language and the user profile team can use a totally different one, picking the absolute best tool for their specific job.
But, a city full of independent buildings would be chaos without roads, traffic lights, and some rules of the road, right? Same thing here. For this whole city of services to work together like a single app, you need some rules and infrastructure. In the tech world, we call these design patterns.
Rule number one is the API gateway. Think of it like the Grand Central Station or the main front door for the entire city. Instead of you needing to know the exact address of every single little service, you just send all your requests to this one central spot. The gateway then acts like a smart traffic cop, routing everything where it needs to go.
Now this next one is a big deal. For services to be truly independent, you need the database per service pattern. The rule is simple. The user service owns and protects its user database. The product service owns its own product database, and they are absolutely forbidden from touching each other's data directly. This is the pattern that finally solves that old monolithic problem of one giant, messy database.
Okay, but what about a complicated process, like placing an order online? That has to touch a bunch of different services. How does that work without becoming a mess? Well, for that, we have something called the saga pattern. It's basically a managed chain reaction. The order service kicks it off, then it tells the payment service to do its part.
which then triggers the inventory service, and so on down the line. It's a structured workflow that makes sure these complex, multi-step jobs get done reliably.
Now, it's not all sunshine and rainbows. I mean, running an entire city is obviously way more complicated than managing a single building, right? This new distributed world is incredibly powerful, but with great power comes a whole new set of challenges that need a whole new set of tools.
For starters, how on earth do you make sure everything works when you have hundreds of moving parts? You can't just test one little thing and call it a day. You need layers of testing, kind of like a pyramid. At the bottom, you test the tiny individual components. Then you use contract testing to make sure their APIs still match up. Then you test how groups of services interact. And finally, at the very top, you run tests that simulate a real user's journey from start to finish.
And what happens when something breaks in this massive city? How do you find it? You need a superpower called observability. This means first, having centralized logging, so all the messages from all the services go to one place. Second, you need distributed tracing, which lets you follow a single user's request as it literally bounces from one service to the next, so you can see exactly where things went wrong. And finally, you need metrics to give you that 30,000-foot view of the entire city's health. So I know this can all sound a bit technical and abstract, but I promise you, you are using microservice architectures every single day. Let's talk about how this stuff actually powers the digital world you live in.
Whether you're shopping on an e-commerce site, streaming your favorite show, or checking your bank balance on an app, you are deep inside a microservices world. Streaming platforms separate your user profile from the actual video delivery so they can handle massive traffic spikes. E-commerce sites make sure that if the product recommendation service fails, you can still put things in your cart and check out. This architecture is literally everywhere.
And this right here, this quote gets to the absolute heart of why companies go through all this trouble. The ability for one small team to update their little piece of the universe without having to coordinate a massive, risky redeployment of the entire application, that is the ultimate key to moving fast and staying competitive.
And just to give you a sense of the scale we're talking about here, the major platforms you use every day aren't running on 10 or 20 services. They are running on thousands of independent services, all working together behind the scenes to create that smooth experience you get.
So look, microservices are incredibly powerful. There's no doubt about it. But that power comes with the price tag of complexity, and you don't always need it. And that leads us to a final, really important question to think about. For a small team just starting out, or for a brand new project, when might that simple, old-school monolith actually be the smarter choice?